Hey everybody, ready for the third, number 3 Trig Y video? I'm Alan Farner. Let's hop right in. So, to get started, why do trig functions work? Let's talk about what trig functions are. And trig functions are definitions of ratios. For instance, sine is opposite, get this to draw correctly, opposite over hypotenuse. Cosine is adjacent over hypotenuse, and if you think about it, I didn't draw that. Let's have a triangle. Let's have theta as our angle, and this is going to be adjacent. This is going to be opposite, and this is going to be hypotenuse. And we know that the hypotenuse square, or we'll go hypotenuse equals the square root of adjacent squared plus opposite squared, and that's because of the Pythagorean theorem, c squared equals a squared plus b squared, when it comes to a right triangle. So there are definitions, and I think this is important because further along in the trigonometry course, further on in a trigonometry course, see, I can say it more than once in a row correctly, you'll learn about identities and stuff, and those aren't definitions, those are identities. They say that every time if you take this, it equals that. These are definitions, and they're ratios, and that's really why trig functions work, because they're ratios. And ratios, the ratio does not usually change based on size. So let's look and say, and we're almost done, don't worry. Let's look at a triangle. So what we have here is a y equals x line, and we're going to draw a triangle by going with spot 2, 2, right there, 2, 2. Well, if we look at it, it's a, well, let's see, it'd be 1, 1 would be, so 2, this is going to be 2, obviously, this is going to be 2, and this is going to be 2 square roots of 2, okay? Good enough? It's a 45-degree angle if we were to look at the angle in here. So when you figure out, let's go with tangent because that's going to be the easy one. If you figure out tangent, it's going to be 2 over 2, which equals 1, right? So the tangent of, we'll call this one alpha, the tangent of alpha is equal to 1. Well, we want to make the triangle bigger. We want to show how we still get a tangent of 1, even if it's bigger. So let's say we continue along this line and we double its size, right? So in this case, the original case, y equals 2, we're going to go twice the height to 4, 4, and now y equals 4. Well, let's say tangent, notice theta. Theta has not changed at all. It stayed the same. We didn't move the line's angle up or down. It stayed the same. Now it's 4. Well, tangent of alpha is now 4 over 4, which equals 1 still. And that is why the trigonometric functions work. They are a ratio. And it doesn't matter how big, because we could go the other direction. We could go to spot 1, 1, and then 1 is going to be the opposite side, and 1 is going to be the adjacent side, and we're still going to get a tangent of 1. They are ratios. They don't matter how big or how small they are. The ratio is going to remain the same because the component parts of the ratio increase or decrease equivalently. Does that make sense? What do you think? Thanks for watching. Hope to see you in the next one.